So let's talk about some linear function applications, specifically with total cost and marginal cost. So total cost, what this is finding is the total cost of producing, and typically the variable that we use is Q. So typical cost of producing Q items, where Q is just representing the quantity of items. So what we're going to see with this section with linear functions is this coming through as a linear equation. So our linear equations or linear functions, let's stick to function notation to stay on theme here. So f of x equals m times x plus b. So with our typical linear notation there, so remember m is the slope or rate of change, and b is our y-intercept, or in terms of word problems, this would be an initial value. So in the context of producing items and the cost of producing items, let's actually start with b, the y-intercept value. What this will come through as is a cost that's incurred no matter how many items you make. In fact, it's really the idea of if you made 0 items, this is the cost that you're dealing with. This is often referred to as the fixed cost. So fixed cost, or FC for short, is kind of, it's hard to describe it without just saying fixed cost, but basically it's a cost that you incur no matter what. Then the slope is described as a variable cost. This is a cost that changes depending on the number of items you produce. Typically this is described as a rate, so like dollar per item, that would be your variable cost. Whereas fixed cost is just some flat cost that's incurred once right at the beginning, and that's it. But variable cost typically increases with the number of items you're producing. So to calculate total cost of some certain number of items that we're producing, so TC for total cost of Q items is going to come from, and what we're doing is just making substitutions where variable cost is M, fixed cost is B. I'm going to switch the order a little bit because typically fixed cost is easier to see from the wording of our question. So we're going to we take the fixed cost plus our variable cost times however many items we're producing. Now the marginal cost, let's just separate this out a little bit. So the marginal cost is the change in total cost if we increase the quantity by 1. So it's the change in total cost if the quantity increases by just 1. So in terms of function notation, what this would look like is calculating the total cost of producing Q plus 1 items, so the idea of producing 1 additional item, and subtract out the total cost of just producing Q items. So we're looking at the difference and this change of just producing that 1 extra item. Okay, let's look at some examples here. So we have the total cost in dollars to produce Q units of a good is given by the function C of Q equals 20.5 Q plus 84,000. And just to interpret what the function itself is telling us, so that 20.5 is our variable cost and that 84,000 is our fixed cost. So just reading that notation there, and it's not going to ask questions about this, but just in case a question like this comes up, this would tell me that there is an initial cost or a fixed cost of $84,000, and then a cost of $20.50 per item. So in words, that's what this formula is describing as. It's linear, since we just have a value times our variable plus an initial value. So we have our slope and intercept. The 84,000 is describing this like it could be just running the plant or salary or things that are going to be incurred no matter what. And then depending on how many items they make that day or that week, depending on how this function works, $20.50 per item. So that's part of the production of the good. Okay, so what is the total cost to produce 700 units? So this, we're just looking at C of 700. So we're going equals 20.5 times 700 plus 84,000. And with that, we can just plug that into the calculator. And that's 98,350. So as a sentence, we could say the total cost to produce 700 units is $98,350. Okay. What is the cost of the 700 first item? So C of 701 equals 20.5 times 700. Nope, 701 plus 84,000 equals, and with this, let's go ahead back to our calculator. What's really nice about Desmos is you could just edit your original equation. So 98,370.5, 370.5. So what is the cost? So we just found what is the total cost. Ooh, sorry. So this right here, let's call this out. So the total cost to produce 701 units is $98,370.50. But this question here asking for the cost of the 700 first item, just that extra item, this is the idea of marginal cost. So what's it going to cost to make this one extra item? If we made 700, what's one additional item going to cost? So this marginal cost, so MC, is going to equal, and we're going to take this 701 value, so 98,370.5, and subtract out 98,350. And this shouldn't be too much of a surprise, but it should be 20.5. And why it came out to be equal to our variable cost is because this is linear. With a linear function, the slope stays the same. So it doesn't matter how many units we produced, to produce an extra unit is going to just be equal to the variable cost every single time. Once we change this type of function, then the variable cost will change value to value. But with this one, it could have been anywhere, and we would have had this marginal cost of 20.5. So let's go with the marginal cost is $20.50 when production is 700 items. So when we're at 700 items, to produce one extra item would cost $20.50. Let's look at a case that's not linear. So this one we have a square root in our function. So company has determined the total cost of producing Q items is T of Q equals 2,000 plus 50 times the square root of Q. And we want to find the marginal cost when production is currently 5,000 items. So basically we're looking at this interval where we want to compare 5,000 to 5,001. So this marginal cost of 5,000 items is going to come from taking the total cost of 5,001 items minus the total cost of 5,000 items. So what we can do is some work off to the side here, or we'll be kind of relying on our calculator here with that square root. But basically, I want to take this calculation of 2,000 plus 50 times the square root of 5,001, and then subtract this 2,000 plus 50 times the square root of 5,000. And the parentheses are super important here, especially for the second half of the calculation, because we want to subtract all of this here. So the subtraction needs to distribute in. So be sure to have those parentheses over this total calculation for when we have 5,000 items. And with that, we can go to the calculator and let's go ahead and take a look at this. So I'm going to use parentheses to help out here. So 2,000 plus 50, and then we have a square root symbol here of 5,001. I'm going to close parentheses, subtract, start parentheses, 2,000 plus 50 times that square root of 5,000. And we're getting a 0.353536. Let's go to 4 decimal places. 0.3535. However, in the context of this, so this is marginal cost. So what we're looking at here is in money. So really this is the equivalent of 35 cents. So making a sentence, we would say the marginal cost is 35 cents when production is 5,000 items. So if they're producing 5,000 items, to produce one extra item would cost them 35 cents. Now just to compare how this would change, because like with that first example, it was linear, so that marginal cost was always the same. This is not linear, this is a radical function. So let's see if we just changed in the calculator, instead of 5,001 and 5,000, let's just change this to 501 and 500. Notice then the marginal cost is $1.12. So marginal cost is larger when production's low, but when you're producing a ton of items, to do just one more isn't as impactful. So a few ideas here, but mostly all relating to this idea of production costs with a company. So finding total cost, if it's linear, then you have this fixed cost and variable cost relating to intercept and slope. If we want to find marginal cost, we just want the difference of producing one more item, subtracting that level of production that they're looking at.